Okay, now how are vectors represented graphically? So in graphical representation of vectors, vectors are represented by a line. A line. A line with head and a tail. So this is the head and this is the tail of the line. So the length of the line represents magnitude of a given vector. And the direction of the line is represented by the position of this line, right? So example is if the given vector is, we say vector A has a magnitude of 5 Newton and then a direction of 25 degrees from positive x-axis in counterclockwise direction, how can we make a line of 5 Newton? It's easy if it's length like 5 cm, 5 meters, but for 5 Newton, we cannot just put 5 Newton lines. We will do scaling. Example, if you want 1 cm is to 1 Newton, then 5 Newton is equivalent to 5 centimeter long line. So you do scaling. About velocity, like 5 kilometers per second, we cannot make a line of 5 kilometers per second in a, say, graphing paper. We cannot make a line, or any paper, we cannot draw a line that is equivalent to 5, uh, 5 meters per second. So what they're going to do is do scaling. They say 1 inch is equivalent to 1 meter per second. So make a line that is 5 meter long or 5 inches long, and that is equivalent to 5 meters per second. Okay, and then we have the so-called free vector. Vector can be moved anywhere in space, any region of space, provided that the magnitude and direction are not changed. Suppose I have vector here, a given vector. All right. Now, so if that is the position and the length of the vector, I can move the vector here. I can move this vector here. I can move the vector here without changing its magnitude and its position. So I can move anywhere in two-dimensional space. By the way, so this is a two-dimensional vector. We will talk about later on more than two-dimension vector, that is, let's say, three-dimensional vector. So in two-dimensional space, you can move this vector anywhere in this two-dimensional space, provided that the magnitude and direction are not changed. Now, so if two vectors are equal, then two vectors have the same magnitude and direction. Okay. Now, displace, for example, this one, if this is vector A, then this is also vector A. They have the same magnitude and direction. Now, if this is what we call the negative vector, they have the same. Vector B is equal to negative vector A if vector A has magnitude equal to vector B but pointing in opposite direction of vector B. So if vector B is pointing at that direction, then vector A should point at opposite direction. So that is negative vector. So how will we add vectors graphically? So two vectors may be added graphically using either parallelogram method or head-to-tail method. So in adding two or more vectors, you must lay the vectors one after another with the tail of the succeeding vector placed at the tip or head of the preceding vector. So, and then we need to draw a vector from the tail of the first vector to the head of the last vector. Okay, the line that is drawn from the tail of the first vector to the head of last vector represents vector sum. Okay, so how can we add these two vectors? Let's say vector A and vector B, and vector C is the vector sum of these two vectors. So we can add, we have the so-called free vector. So You can put vector B at this region of two-dimensional space, and then you can transfer, but still this is vector C. Or this one, we can also add them by constructing a parallelogram method. Okay. Make a line parallel to B and the same length of B, and then make a line here the same length to A and also the same position. And then the sum of two parallel vectors, let's say if this is vector A and this is vector B, then all are pointing to the right, then vector C has the direction to the right, exactly to the right. Okay, what are these anti-parallel vectors? Anti-parallel vectors, it means these two vectors are pointing in opposite direction, though they don't have the same magnitude. For example, vector A has uh, greater magnitude compared to vector B, but these two vectors are pointing in opposite direction. Because let's say vector A has a magnitude of 5 and vector B has a magnitude of 2. So that's 5 minus 2, then vector C has magnitude of 3. Okay. Now, in adding vectors, this is not like adding scalar quantities. For example, if you're going to add 3 plus 5, that's equal to 8. That's for scalar. But for vectors, 3 plus 5 is not always 8 because it depends on the direction of each vector. So these are the sum of anti-parallel vectors. So we need to lay the vectors one after another with the tail of succeeding vector placed at the head or the tip of the preceding vector. And the vector drawn from the tail of the first vector to the head of the tip of the last vector represents the vector sum. So I have here, suppose we're going to okay, suppose we're going to add okay, suppose we're going to add these three vectors. So we need to lay the vectors one after another. We look for uh, looking for vector A plus vector B plus vector C. Okay, and that's vector S as the sum of these three vectors. Okay, so we need to lay. Suppose this is the uh, position of vector B. This is the position of vector A. This is the position of vector B. And then this is the position of vector C. Okay. Suppose this is the position of vector A and this is the position of vector B and this is the position of vector C. We have the so-called free vector. We can move the vectors anywhere in the region of space provided that there's no change of magnitude and direction. All right. So how to add graphically? We need to lay the vectors one after another. So we'll start at vector A. So we lay the vector A and then next vector B without changing its position and length. Okay. And then next is vector C. So the succeeding vector is vector A. The succeeding vector of vector A. I mean, vector B is the succeeding vector of vector A. And then vector A is the preceding vector of vector B. So I need to put the tail of vector B to the head of vector A. And then vector C is the succeeding vector of vector B. So I need to put the tail of vector C to the head of vector A. And the line drawn from that the tail of the first vector to the head of last vector represents sum. So this is vector S. Now, in adding more than two vectors graphically, we can use head-to-tail method, but we cannot use the parallelogram method. Parallelogram method is only good for two vectors, adding two vectors. Suppose you need to add vector A, vector B, and vector C, and these are the positions of three vectors. So what are you going to do? You can add first vector A and vector B, and let's say the sum of these two vectors is vector D, and then add vector D and vector C, and we'll get vector R as the vector sum. Or you can add first vector B and vector C, then it's the sum of vector B and vector C represented by vector E will be added to vector A, and we have vector R as the sum or the vector sum. Or you can add these three directly. Vector A plus vector B plus vector C is equal to vector R. And then you can add, you can make a line of vector B first and then next vector A, but putting the tail of vector A to the head of vector B, and then the tail of vector C to the head of vector A, and then draw a line from the tail of vector B to the head of vector C, and that represents vector R. So example, okay, suppose these are the three vectors, vector C, vector A, vector B, and vector C. So these are the positions of the given three vectors. So you can add, you can start anywhere. We're looking for, say, vector A plus vector B plus vector C. Okay, I'll mark that as vector S as the sum of these three vectors, right? So you can start at A and then next to B by putting the tail of vector B to the head of vector A, and then next to lay vector C by placing the tail of vector C to the head of vector B, and then draw a line from the tail of vector A to vector C. So this one represents vector sum of these three vectors. Or you can start at B. Since this is positive, then we have vector B. You can start at vector B. Make sure these three vectors, the position and direction of these three vectors are not changed. So here, this is vector B plus vector A plus vector C. So this is still the same. The position of the vector sum and the magnitude is still the same. So what if I'll start at vector A first, vector A, and then next is vector C, and then next is vector B. The vector sum is the same. Okay, they will have properties of vector later on. So in physics, um, the direction of vectors is usually measured from positive x-axis in counterclockwise direction. The x-axis uh, is usually the reference frame. One of the properties of vector is the what we call the commutative property of vectors. Suppose we're going to add vector A and then vector B, and the resultant, the sum of vectors presented by vector R. So if you're going to draw a line from the tail of the first vector, which is vector A, to the head of vector B is the last vector, and this one represents vector A plus vector B. And then we have the so-called free vector. We can move the vector anywhere in space, provided that the vectors, or any vector, the magnitude and the direction of any vector uh, change. So I can transfer vector B here, this position, and vector A at that region of space. So if I make a line from the tail of vector B to the head of vector A, then this line represents vector B plus vector A. But still, the position, this is the representation of the sum of these two vectors, vector A and vector B, which is represented by vector R. But look at vector R. It is the magnitude and direction is still the same, no matter how you move vector A and vector B. So meaning, in this property, the commutative property, the order in which the vector are added does not affect the results. So now, suppose this is vector A, this vector here as is vector A, and this is vector B. So this line represents vector A plus vector B. Okay, and we have this so-called free vector. So if I'm going to move vector A without changing its position, still pointing at this direction, and the magnitude is the same, the length is the same. Okay, so this is now the vector A, and then vector B, vector B will be moved. All right, so this is now vector B. Since this line is drawn from the tail of vector B to the head of vector A, then this is vector B plus vector A. So I name vector A plus vector B equals vector B plus vector A. Okay? The order in which the vector are added does not affect the results or the vector sum. So that is the commutative property of a vector. Now, another property of vector is what we call associative property of vector. Suppose we have here three vectors, vector B, vector A, vector B, and vector C. So here, vector B and vector C is added first. Then vector A is added to the sum of vector B plus vector C. So we group together vector B and vector C. This line here represents the sum of these three vectors. Right? So in this case, vector A and vector B is added first, and then the sum of vector A and vector B is added to vector C. But the resultant vector is the same, even if you added first vector A and vector B. Now, suppose we have here three vectors, vector A, vector B, and vector C. So we're going to add vector A and vector B first. So we will make a line from the tail of vector A to the head of vector B. This one represents vector A plus vector B. Right. And then this one, we make a line from the tail of vector A plus vector B to the head of vector C. Okay, so we added first vector A and vector B. So this line represents vector A plus vector B. We group together. This is vector A plus vector B. We group together vector A and vector B first, and the next is added by vector C. Or we can do this way. you can add first vector B and vector C. Okay, so this line represents vector B plus vector C. And then we'll make another line from the tail of vector A to the head of vector C. So this line vector A represents vector A plus the sum of vector B and vector C. And this line is the length and the magnitude and position of vector, the resultant vector is the same, or the sum of these three vectors is the same. So meaning, we first group together vector A and B and then add it to vector C. The second one, vector B and vector C are grouped together, and then vector A is added to vector B and vector C. So meaning, grouping of the addends, which are the vector A, vector B, and vector C, does not affect the vector sum. So that is what we call the associative property of vectors. In adding vectors, you cannot add vectors that do not have the same unit. For example, you cannot add 5 centimeter into 5 Newton, or 5 Newton plus 3 meters per second. When adding vectors, all of the vectors must have the same units. All of the vectors must be in the same type of quantity. So you cannot add the quantity of length to quantity of force. You cannot add quantity of speed to a quantity of length. When you add vectors, length must be added to length. Newton must be added to Newton, or force must be added to force, speed must be added to speed, velocity must be added to velocity. They must have the same unit. Now, if one is in centimeter and the other one is meter, you need to convert either from centimeter to meter or meter to centimeter. Okay, one example, you cannot add displacement to a velocity. A negative vector is defined as the vector that when added to the original vector given a resultant vector. Still remember, if this is vector A, that is vector A, then the negative of this vector, vector A, must point opposite direction. And these two vectors must have the same magnitude. This is vector A, pointing opposite direction of negative vector A is pointing to the opposite direction of vector A, but they have the same magnitude. But when you add these two vectors, when you add the negative vector of a given vector, the sum is 0. That's which also in scalar quantity, if we have negative 3 plus 3, that is equal to 0. And then negative 5 plus 5 equals 0. Okay. So the negative of the vector will have the same magnitude but point in the opposite direction. Now in subtracting vectors, suppose we have two vectors here, given two vectors, vector A and vector B, and then we're looking for vector A minus vector B. It is just like vector A plus the negative of vector B. So we'll continue with the standard vector addition procedure using graphical method. So we need to lay the vector one after another by placing the tail of the succeeding vector to the head of the preceding vector. So we will lay first vector A and then vector B. So instead of pointing at that direction, since this is a negative vector of negative of vector B, instead of pointing at a direction, you go to the opposite direction but in equal magnitude. So again, instead of pointing at that direction for vector B, instead of pointing at that direction, you go to the opposite direction. So this line here represents vector A minus vector B, right? Or you may lay the vector first. Uh, let's say vector A minus vector B. So vector B and then vector C. So the resultant vector, the line of the resultant vector must be drawn from the head of vector B to the head of vector A. So this is another way of subtracting vectors. So another way to look at subtraction is to find the vector that added to the second vector gives you first vector. So you have vector A plus negative vector B equals vector C. As shown, the resultant vector points from the tip of the second to the tip of the first. So this, you may use this method given two vectors. So from the from the head of the second vector and then to the head of the first vector, it represents vector A minus vector B.